Hello students, welcome back. We're going to be looking at balancing chemical equations. Now the law of conservation of mass will be the driving force behind balancing chemical equations. That law, it states matter cannot be created or destroyed. Sure, most of y'all already know that. What that means is when we have a reaction take place, whatever atoms or whatever elements you have in that reaction, they will still exist, they will still be maintained, they will still occur when the products of that reaction are produced. So if you have a couple of atoms of hydrogen in the reactants, once the products are produced, those couple of atoms of hydrogen will still be present. So if I were to have water synthesis, for example, and I had some hydrogen gas and some oxygen gas, and I cause a reaction between those two, I should produce some water. It's a pretty simple reaction, but it gets a little bit more complicated when you look deeper into it. So what we really have for hydrogen gas, if you remember your nomenclature, is H2. Then we're going to react it with oxygen gas, which is O2. And we are going to produce the product water, which is H2O. So there's our reaction. But immediately you should notice a problem. And that problem is the amounts of these atoms. I have two hydrogen atoms in hydrogen gas. I have two hydrogen atoms in water. That's fine. That's good. In oxygen, I got two oxygen atoms. But in water, I only have one. So where did that other atom go? But according to the law of conservation of mass, it should still be there because it can't just disappear. It's still a part of this reaction. So we got to do what's called balance the equation. So to do that, we got to make the left side, which is the reactant side, equal to the right side, which is the product side. And we need to have the atoms of those elements be in equal amounts. So if this reactant side has two hydrogen atoms, then the product side has to have the same amount. It has to have two hydrogen atoms. If the reactant side has two oxygen atoms, then the product side has to have two oxygen atoms. And right now, that is not the case. Right now, we are not following the law of conservation of mass. So what we have to do is balance the equation. Now, some people may look at it and go, well, if I just stick another 2 right here, it's balanced because now I got two hydrogens and I got two hydrogens. I got two oxygens and I got two oxygens. It's balanced, right? Not quite, because once you stick that 2 on H2O, it becomes H2O2. It is no longer water. It's now hydrogen peroxide, something you don't want to drink. So we can't do that. We can't just change the subscripts of our compounds, because if you change the subscript, you change the compound completely. So we can't do that. So what we got to do is add coefficients. A coefficient is going to be a large number we stick in front of these compound species, and it's going to multiply everything beside it until you get to one of the signs, either a plus sign or an arrow sign. So let's look at this one. I got two hydrogens and two hydrogens. So that's fine. These two at the moment are good. My hydrogen is good. So we got to fix this oxygen. It has two oxygen atoms. The product side only has one oxygen atom, so we got to fix that. So what we do is we add a coefficient. So I take that water molecule and I multiply it by 2. So that gives me 2 oxygen atoms on the product side, and I got 2 oxygen atoms on the reactant side. So now my oxygen's good. But now we have a new problem. And our new problem is my hydrogen atoms. Now I have 2 times 2 is 4 hydrogens. And on this side I only have 2 hydrogen atoms. So that's a problem now. So we're no longer good. So we got to fix that. We're no longer good. So if this product side has 4 hydrogen atoms and my reactant side only has 2, how can I fix that? Well, 2 goes into 4 2 times, so I'd put another coefficient, a coefficient of 2. So now I have 4 hydrogen atoms on my reactant side. I have 4 hydrogen atoms on my product side. 2 oxygen atoms, 2 oxygen atoms. Now everything is in balance. And that, in its simplest form, is balancing equations. Trying to get the atoms on the reactant side equal in the same amount to the atoms on the product side for each unique element. Sometimes this can be challenging, sometimes it can be very easy, but practice is your best friend on this one. The more you do it, the better you become. And there are some tricks along the way that you'll learn to help you do it a little bit quicker and a little bit easier. So let's look at a couple of practice problems just to see if we can get the hang of this. Sometimes people like to make little charts of all their elements to make things a little bit easier. Some people don't like to do that. It's all a matter of preference. And this time I'm going to write out my elements to make it a little bit more visual. So I have 2 sides to my reaction. I have the reactant side. I have a product side. So anytime you see this arrow, that's going to be the separation of your reactants and products. That's the yield sign. So those are the 2 sides you're trying to balance. The left side of the arrow and the right side of the arrow. Anytime you see a plus sign, those separate different atoms and elements, different compounds. But if you see 2 of the same elements just separated by a plus sign, you want to add those quantities together. So let's just take a look at this first one. I got iron, I got chlorine, I got iron, I got chlorine. So on my reactant side I have 1 iron. On my product side I have 1 iron. Well, that's balanced. That's okay for now. So let's move on to the next. On my reactant I have 2 chlorines. On my product I have 3 chlorines. Well, that's not balanced. That's not going to work. So we got to fix that. So you got to ask yourself, what number can both 2 and 3 go into? Well, 2 and 3 can both go into 6. So how do we get 6? Well, 6 divided by 2 is 3. So if I multiply this 3 by 2, I'll get 6. So this chlorine on this side needs to be multiplied by 3. So the chlorine on my product side, we want to get it to 6. So 3 times 2 gives me 6. So this chlorine on the product side needs to be multiplied by 2. When we add this coefficient here, the coefficient multiplies everything to the side of it, to the right side of it, until you get to a sign. That means it's also going to multiply this iron atom by 2. So now I have 2 irons. On this side I still only got 1, so now I got to fix that. So you got to ask yourself, what number can both 1 and 2 go into? Well, 1 can go into 2 2 times. So if I multiply this side by 2 as well, I'll get 2. So this iron on the reactant side, it needs to be multiplied by 2. So then we go back and check our work. I got 2 irons. I got 2 irons. So iron is good. I check my chlorine. 3 times 2 is 6 chlorines. 2 times 3 is 6 chlorines. So my chlorine is good. So now my equation is balanced. Now we're following that law of conservation of mass. Let's look at the next problem. Got nitrogen plus hydrogen producing ammonia. So let's separate our sides to products and reactants. Identify what elements we have to balance. So I got a nitrogen, a hydrogen, nitrogen, and a hydrogen. This side has 2 nitrogens. The reactant side has 2 nitrogens and 2 hydrogens. Product side has 1 nitrogen and 3 hydrogens. Alright, now we got it separated, now we got everything identified, we can balance our equation. I'm going to start with nitrogen since it comes first. So I got 2 nitrogens on the reactant, 1 nitrogen on the product, so I need to balance that. 1 can go into 2 times. So if I multiply this one by 2, then I'll be balanced. So my product nitrogen needs to be multiplied with a coefficient of 2. That balances my nitrogens. Those are good. I got 2 and 2 now. But it changes my hydrogen. As soon as I put this coefficient right here, it also multiplies the hydrogen. So 2 times 3. So 2 times 3 is 6 hydrogen on the product side, and I only got 2 on the reactant. So I got 2 and 6. How can I fix that? Well, 2 goes into 6 3 times. So if I multiply this by 3, it'll give me 6. So this hydrogen right here is going to get multiplied by 3. So I got 3 times 2, which gives me 6 hydrogens. On the product side, I got 2 times 3 is 6 hydrogens. So my hydrogens are now balanced. Alright, let's do another example. Alright, so let's separate our sides. I have a phosphorus, I have oxygen, phosphorus, and oxygen. Reactant side has 1 phosphorus, 2 oxygen. Product side has 2 phosphorus and 5 oxygen. Now, usually it doesn't matter where you start, but this time I'm going to choose to start at the end because I see that 5 right there. That's a large odd number. Odd numbers make things hard to balance. So one strategy I like to try first is if I see a large odd number, I immediately double it. So I just right off the bat, I multiply that by 2. So 5 times 2 gives me 10. So I'm going to multiply this whole compound by 2 just to make that odd number even. So now, since I multiplied this compound by 2, it also multiplies my phosphorus by 2. So my phosphorus will now be 4. Now, let's try and see if we can balance it. Let's continue on with phosphorus. I have 4 phosphorus on my product side. I have 1 on my reactant. Well, 1 goes into 4 times. So if I multiply this by 4, it'll give me 4. So I just want to put a coefficient of 4 here. And that gives me 4 phosphorus, 4 phosphorus. So far, my phosphorus are okay. Next, we move on to the oxygen. On my product side, I got 10. On my reactant side, I got 2. Well, 2 can go into 10 5 times. So if I multiply this by 5, it'll give me 10. So my oxygen side needs to be multiplied by that 5. 5 times 2 is 10. 2 times 5 is 10. My oxygens are balanced. Everything's good now. Alright, next problem. We've got the combustion of propane. This one looks a little bit more tricky, but we'll see if we can handle it. So like the rest of them, I'm going to separate my sides, identify my elements. I got carbon, hydrogen, and oxygen. This time we have 3 elements. Carbon, hydrogen, and oxygen. Now anytime I see problems like these, one thing I like to do is I always save this oxygen gas for last. It's always the easiest to balance if you save it for last. I typically start with the big carbon molecule, work my way through it, save oxygen for last. So let's try that and see what we get. So I got 3 carbons, 8 hydrogen, 2 oxygen. 1 carbon, 2 hydrogen. Now my oxygen, if you remember from earlier, we said if you got the same element on one side but separated by a plus sign, you got to add those together. So that means I have 3 oxygen because 2 plus 1 is 3. Alright, now with that information, let's get started. I got 3 carbon, I got 1 carbon. Well, 1 goes into 3 times. If I multiply this by 3, I'll get 3. So let's try a 3 right here. My carbons are fine now. Now when you stick this coefficient of 3 in front of CO2, it does multiply your oxygen by 3 and changes this to 6, plus the other one makes it 7. But we said we're going to save this oxygen for last, so I'm also going to save this oxygen for last because I want to go ahead and get this coefficient as well. So I'm going to ignore this 3 multiplying the 2 just for the moment. So let's do our hydrogen next. I have 8 hydrogen. I have 2 hydrogen. Well, 2 goes into 8 4 times. So if I multiply this side by 4, I'll get that 8. So I multiply my water by 4. 4 times 2 is 8. This side has 8, so now my hydrogens seem to be okay. But now we got to recount our oxygen. It is no longer 3. It is no longer that 3. So 3 times 2 is 6, plus 4 times 1 is 4. So I got 10 total oxygen on my product side. On my reactant side, I only have 2. Well, 2 goes into 10 5 times. So 2 times 5 is 10. So if I multiply this oxygen by 5, it should get us there. But I always want to double check our work though. So let's do that. So 3 carbon, 3 carbon. So my carbons are fine. I got 8 hydrogen. 4 times 2 is 8 hydrogen. So my hydrogen is fine. 5 times 2 is 10. 3 times 2 is 6. Plus another 4 is 10. So my oxygens are also good. Looks like we are completely balanced. So remember, the trick to balancing equations is practice. The more you do it, the better you get. Most times balancing equations starts off very easy and then it ends up getting quite challenging. So always practice balancing equations as much as you can so you can get better at it. I hope this video helped. And as always, good luck on your tests.